Hello students, welcome back to chemistry class. Today onwards, we are going to unit number 4 about the hydrogen. Okay, in this unit, what are the topics we are going to study? First of all, introduction about the hydrogen and position of hydrogen in periodic table and isotopes of hydrogen, ortho and parahydrogen, preparation of hydrogen, properties of hydrogen and uses of hydrogen. After that, we're going to study about water. Okay, water and chemical properties of water and hard water and soft water and hydrogen peroxide preparation and uses and structure of hydrogen peroxide. After that, hydrogen bonding, intermolecular hydrogen bonding, intramolecular hydrogen bonding. For all that's all we are going to study in this unit. Okay, first upon today we are going to study about introduction about hydrogen and the position in periodic table. Which position occupy the hydrogen in the periodic table and isotopes of hydrogen. These three topics today we are going to study. Listen carefully, take notes. Very important lesson. Okay, first upon introduction about hydrogen. The word hydro means water. Hydro means water. Gen means generate. Okay, so hydrogen means it generates the water. We know water means H2O. Okay, without hydrogen nothing has the water. Okay, so hydro means water, gen means generates. That's why the name of hydrogen is formed. Okay, the name of hydrogen is given by Lavoisier, who is the father of chemistry. We know Anthony Lavoisier. He is the discoverer of hydrogen. Understood? Hydrogen, it is one of the simplest atom which contain one proton and one electron. Okay, hydrogen is the simplest atom which contain one proton and one electron. Okay, and it is present in most of the compounds we come across in our daily life, such as water, carbohydrate, proteins, etc. etc. Okay, the hydrogen has an unpaired electron. You know hydrogen, what is the atomic number for hydrogen? 1. Atomic number for hydrogen 1. Electronic configuration 1s2, 1s1. So orbital diagram, only one s orbit is present in the hydrogen atom. Only one electrons are having here. Okay, so this is called this is the unpaired electron, not pairing up. Okay, unpaired electron. Because of this unpaired electron, the hydrogen is very reactive. Okay, and hydrogen gas in the Earth's atmosphere is very small. Hydrogen gas in the Earth's atmosphere is very small. Hydrogen in the form of water. Okay, hydrogen having the form of water drops, etc. And other compounds, carbohydrate, proteins, etc. Okay, hydrogen gas in this atmosphere is very small amount of hydrogen gas exists in our Earth's atmosphere. Understood? These are about the introduction. Then we are going to study about position of hydrogen in periodic table. Position of hydrogen in periodic table. We know the position of hydrogen in the periodic table. This is the modern periodic table. the hydrogen is present in the above the first group. Okay, in this periodic table having 18 groups and 7 periods. In the first period, first group, first place occupied the hydrogen atom. Okay, so why? Because certain similarities exist between alkali metal with hydrogen, and also some similarities exist between halogens. Okay, hydrogen have the similarities with alkali metals and also halogens. Okay, halogens, you know, group 17 elements we called as the halogens. Okay, the properties of some properties of the hydrogen atom like the properties of alkali metals, and also some properties of the hydrogen atom, it is similar to the halogen groups, group 17 elements. Alkali metal means group 1 elements. Okay, because of this, it is difficult to find the right position of hydrogen in periodic table, and the position, actual correct position of hydrogen in the periodic table is till date not resolved. Okay, but accordance of certain similarities with alkali metals of hydrogen is placed in the first element in alkali metal group. Okay, and also some dissimilar character also having like the alkali metal. Okay, similarities having and dissimilarities between the hydrogen and alkali metals are having. Okay, now we are going to study about how the hydrogen atom is similar to alkali metals and how the hydrogen atom is similar to halogens. Okay, and what about the dissimilarities about the alkali metals and halogens between the hydrogen atom. Okay, first, what are the similarities? What are the same character, similar character with alkali metal? Whatever characters similarly alkali metals. Okay, whatever characters, whatever properties are similar to the properties of hydrogen atom is similar to the alkali metals. Now we are going to study. Okay, what are the characters? What are the properties? First, it forms unipositive ion. It forms unipositive ion like alkali metals. It forms unipositive character. What do you mean by unipositive? Uni means one. Uni means one positive character like alkali metals. Okay, understood? What are the alkali metals? What do you mean by alkali metals? What are the group first elements we called as the alkali metals? Okay, what are the elements are having in the group first? Lithium, sodium, potassium, rubidium, cesium, francium. Okay, these are the elements of first group elements. Okay, so hydrogen, the properties of hydrogen is similar to the alkali metals. Okay, whatever characters. First one, unipositive character. Unipositive forms unipositive like alkali metal. Okay, because we know the alkali metal, lithium, sodium, potassium, rubidium, cesium, okay, and hydrogen, all the elements having the one valence electron. Okay, all the elements having one valence electron. Okay, when lithium when it lost one electron, it forms unipositive ion. Okay, like that sodium only one valence electron having. So it is easy to remove this one electron to form unipositive ion. Okay, like that potassium, only one valence electron, it can be easily lost this one electron because it is try to attain the octet configuration. Okay, so it try to lose this one electron easily. Okay, so potassium atom, it remove one electron to form unipositive ion. Like that, hydrogen also having the one electron. Hydrogen atom, only one electrons are having. So it is try to lose this one electron to form hydrogen ion. Okay, this is the first similarity. What is the second similarity? What is the second similarity like alkali metal? So alkali metals react with oxygen to form the corresponding metal oxide. Okay, for example, lithium. When lithium, it combines with oxygen to form lithium oxide. Like that, sodium, it combines with oxygen to form sodium oxide. Like that, when hydrogen, it combines with oxygen to form hydrogen oxide. Hydrogen oxide. We call this is the water. That is water. Okay. So this second similarity. What is the second similarity? It forms oxides, peroxides, sulfides, halides, like alkali metals. Okay. It forms oxides, hydrogen halides, HX means hydrogen halides, and hydrogen sulfides, like alkali metal. This is the similarity, second similar character between the hydrogen and the alkali metals. Okay, and what is the third similarity? What is the third similarity? It is also acts as the reducing agent. Hydrogen also acts as the reducing agent. What do you mean by reducing agent? Reducing agent means it loses an electron. Okay, it loses its electron in the redox reaction. That is called the reducing agent. Reducing agent, hydrogen, it is acts as the reducing agent because it can easily lose this electron. Understood? These are the three similarities between the alkali metals and hydrogen. We are studying now what is the position of the hydrogen in periodic table. We know the elements are arranged in the increasing order of their atomic number in a modern periodic table, but certain properties of the elements are repeated with regular intervals of atomic number. Okay, similar characters, atoms, elements arranged in the same group. We studied about that clearly. Okay, here what is the position of hydrogen in the periodic table? Now we are studying. Okay, so because hydrogen has the similar characters like alkali metals, and also hydrogen characters of hydrogen, it is similar to the halogens. Okay, so why the place occupy the hydrogen in the first with alkali metals? Okay, now we are studying. Okay, whatever similarities between the hydrogen and alkali metals, the three similarities. First one, it form unipositive ion like alkali metal. Second point, It forms halides, oxides, sulfides like alkali metals. Third point, it also acts as the reducing agent. Okay, but here one of the dissimilar character also having here. One of the dissimilar character also having here. What is the dissimilar character? The alkali metal which have ionization energy ranging from 377 to 520 kilojoule per mole. What is the ionization energy of the alkali metals? It is the ranging from 377 to 520 kilojoule per mole. Because but the hydrogen has 1314 kilojoule per mole ionization energy. Okay, so which is much higher than alkali metal. The ionization energy of hydrogen, it is much higher than ionization energy of alkali metals. Okay, why? Because when moving down the group, ionization energy decrease. Okay, you know, because the distance between the center of the nucleus and outermost electrons is increased. So the nuclear force of attraction decrease between the nucleus and outermost orbit. Okay, but here in the case of hydrogen, only one electron, only one proton and only one electrons are having the outermost shell of hydrogen atom. Okay, so the protons has the mass. Okay, the protons is heavy mass than electron, and the mass of the electron is very low. When comparing the mass of the proton and mass of the electron, mass of the proton is very big than electron. Okay, so the proton, it tightly attracts the electron towards itself. Okay, so it is not easy to remove the electrons. Okay, so when we are removing the electrons from the outermost shell of hydrogen atom, we should give higher energy. Okay, ionization energy, you know, the minimum amount of energy required to remove the electron from the outermost shell of remove the valence electron from the outermost shell. Okay, so here hydrogen atom, it is very near to the electrons, outermost electron of hydrogen atom, it is very closer to the nucleus. Okay, very closer to the nucleus. So the nucleus tightly attracts the electron in outermost shell. So it is difficult to remove this outermost electron. Okay, so we should give more energy to remove the electron. So ionization energy becomes very high than ionization energy of alkali metals. The ionization energy of alkali metals are ranging from 377 to 520 kilojoule per mole. But the ionization energy of hydrogen atom 1314 kilojoule per mole. Okay, so it is very high. It is the dissimilar character of hydrogen and alkali metal. Okay, understood? And then what are the similarities and dissimilarities between the hydrogens and the halogens? Okay, we know the hydrogen atoms having the similar character between the halogens and alkali metals. Okay, now studied, we come to know about the similarities of hydrogen atom with alkali metals and what are the dissimilar character with alkali metals. Okay, now we are going to study about what are the similar properties. Hydrogen atom also shows the properties similar to the group 17 elements, that is halogen family. Okay, let's see how is hydrogen similar to halogens. Okay, all the halogens are one short of electrons in the valence shell, that of the nearest noble gas. Okay, here for fluorine, has one electron less than nearest noble gas. Similarly, chlorine has one electron less in the nearest noble gas. Like all the halogens, hydrogen has one electron less than the nearest noble gas. Okay, so like all the halogens, hydrogen also try to get the noble gas configuration. Okay, so all the halogens gain electron to complete the octet configuration. Okay, fluorine, chlorine, bromine, all the halogens try to gain one electron because the outermost shell having the 7 electrons for the halogens. Okay, so all the halogens try to gain one electron to get the nearest noble gas. Okay, fluorine try to get one electron to get the nearest noble gas of neon. Okay, chlorine try to gain one electron to form the nearest noble gas configuration, argon configuration. Okay, like all the halogens, hydrogen also try to get one electron to form the complete doublet structure, doublet configuration. Okay, that is helium, try to attain the helium configuration. Understood? So hydrogen, when it gain one electron to form hydride ions like halogens. Okay, chlorine, fluorine, bromine, all the halogens also gain one electron to get to form the chloride ions, fluoride ions, etc. So hydrogen also has a tendency to gain one electron to form hydride ion whose electronic configuration is similar to the noble gas helium. Okay, like the formation of halides from halogens, hydrogen also has a tendency to gain one electron to form hydride ion H minus. Okay, here only one electron and only one proton. Hydrogen means hydrogen in ground state having only one proton and only one electron. Okay, so it try to get the stable nearest noble gas structure. Okay, helium, when it gain one electron to form hydride ions. Okay, however, the electron affinity of hydrogen electron, what is the dissimilar character? This is the similarity. What our similarity? All the halogens has one electron less than the nearest noble gas configuration. Like hydrogen has one electron less than the nearest noble gas, that is helium. Okay, so all the halogens try to gain one electron to form the its respective ions. Okay, like that hydrogen also try to gain one electron to form the hydride ions, hydride ion, to get the complete doublet structure. Okay, this is the similarities between hydrogen and halogens. But one of the dissimilarities having also among the hydrogen and the halogens. What are the dissimilar character? The electron affinity of hydrogen is much less than that of halogens. What is the dissimilar character? The electron affinity of hydrogen is much less than that of halogen atoms. Hence, the tendency of hydrogen to form hydride ion is low when compared to the halogens to form halide ions. Okay, so tendency of hydrogen to form hydride ion, it is low when compared to halide ions. Okay, when compared to halogens, halogens to form when it gain one electron to form halide ions. Okay, but hydrogen ion tendency of forming hydride ion, it is very low. This is the dissimilar character. For example, I am taking one of the example, half molecules of hydrogen. Half molecules of hydrogen means one hydrogen atom. Okay, half molecules of hydrogen atom does not exist in free state. So at a combined state, there is a diatomic molecule. Two hydrogen atom combined to form the hydrogen molecule. Here we are taking half molecules of hydrogen means one proton and one electron. Okay, half molecules of hydrogen when accept one electron to form the hydride ion. When accepting the electron, hydrogen atom release the energy, that is called electron affinity. Electron affinity means the amount of energy released when an atom accept the electrons. Okay, here hydrogen atom accept one electron to give the to form hydride ion and it release the energy. Okay, the energy, what is the energy, how much value given? Delta H is equal to plus 36 kilocalories per mole. Okay, and like that bromine, half molecules of bromine, when bromine, one of the halogen, when it accept the electron to form the halide ion, that is bromide ion. But here the delta H value, that is electron affinity value given by difference in enthalpy, delta H is equal to minus 55 kilocalories per mole. Okay, here why it is the negative value? So negative value means the reaction is exothermic. Okay, when we add an electron, we put it in an orbital, leading to increment in energy. Okay, so which leads to instability. So it releases some amount of energy is surrounding. So hence it is the negative enthalpy. Negative enthalpy, it is more than the positive enthalpy. Okay, since it is the exothermic reaction. Endothermic reaction means enthalpy will be positive. Okay, here the more high amount of energy released when bromine accept electrons. Okay, but the hydrogen accept electron, where less amount of energy will be released. Okay, here delta H for the exothermic reaction, delta H is the negative value. So negative value is the more value. Okay, when compared to positive value. Okay, here hydrogen when accepting electron release hydride ion to form a hydride ion and release the low amount of energy. Okay, this is the dissimilarities about between the hydrogen and the halogens. Okay, so hydrogen and halogens having similarities and dissimilarities. Since hydrogen has similarities with alkali metals as well as halogens, it is difficult to find the right position in the periodic table. Okay. However, in most of its compounds, hydrogen exists in +1 oxidation state. Most of the compounds, hydrogen, this is important, most of the compounds, hydrogen exist in +1 oxidation state. For example, we are taking water molecule H2O. What is the oxidation state or valence of the hydrogen here? H2O means water. When water need 2 electrons to get the stable configuration, oxygen, we know what is the outermost valence electron of oxygen? 6. Okay, 6. So it need 2 electron to get the stable configuration. So 2 hydrogen atom added here. When water molecule forming, 2 hydrogen atom combines with 1 oxygen atom. Okay, each hydrogen atom give each 2 electron to the oxygen atom. Okay, so this hydrogen atom give this electron to this oxygen atom. Okay, so it form plus H plus. Okay, +1. When removing the electron to form +1 oxidation state, we get the +1. Okay, when atom lost electron to form the cation. Okay, so positive. Understood? So the most of its compound, hydrogen exists in +1. Like that other compound, hydrogen exists in +1 oxidation state. Okay, so like that all the group 1 elements, that is alkali metals, has the +1 oxidation state. Okay, so it is the reason to place the hydrogen in group 1 along with alkali metals. Okay, as shown in the latest periodic table published by IUPAC. Okay, what is the main reason to place the hydrogen atom in group 1 along with alkali metals? Because most of its compounds hydrogen exist in plus 1 oxidized state like group 1 alkali metals. Understood? These are about the position of hydrogen in periodic table. Then we are going to study about isotopes of hydrogen. What do you mean by isotope? The same element having same atomic number but different mass number. That is called isotope. Okay. For example, here for the hydrogen atom having 3 isotopes. What are the 3 isotopes? Protium, deuterium and tritium. Protium otherwise we call as the hydrogen, and deuterium and tritium. Okay, so the same element, all the 3 elements having the same element, but having the same atomic number, that is 111 for each isotopes hydrogen having same atomic number but mass number only differ. Okay, here for the protium means hydrogen means what is the mass number? Only 1. For deuterium 2 mass number. Tritium, for tritium mass number 3. Okay, so what do you mean by atomic number and what do you mean by mass number? Atomic number means number of protons or number of electrons. Mass number means number of protons and the number of neutrons. Okay, protons and neutrons are present center of the nucleus and electrons are revolving around the nucleus. We know about that. Okay, in the case of for the 3 isotopes of hydrogen, the protium, there is hydrogen having a mass number 1. So only 1 proton and only 1 electrons are having here. Okay, we know all the 3 isotopes having only 1 electron and only 1 protons. But neutrons, number of neutrons only differ here. Number of neutrons only differ here because of the isotopes are forming. Okay, for number of when number of neutrons are vary, the isotopes of the elements are formed. Okay, so here number of neutrons are differ here for deuterium and tritium. For deuterium number of neutrons 2, number of neutron 1, and for tritium number of neutrons 2. But protium no neutrons. Okay, 0 neutrons, 1 proton and only 1 proton and only 1 electrons. Okay, here. So for the deuterium, mass number 2 means number of proton 1, number of neutron 1. For tritium, mass number 3 means number of proton 1, number of neutron 3. Okay. So when we are subtracting from mass number and atomic number, we get the number of neutrons. Okay, and then what are the how many abundance of isotopes of hydrogen? First one protium. What is the abundance? The protium has the higher percentage of abundance in the atmosphere, that is 99.985%. 99.985% of protium having in the Earth's atmosphere. But in the case of deuterium, only 0.015% only having. Okay, but tritium, it is very small amount of tritiums are having in the Earth's atmosphere. The tritium, one of the radioactive isotope. Okay, so one atom, for the 10 power 18 atoms of hydrogen, 1 atom tritium having. Understood? So the existence of these isotopes naturally occurring, that is as hydrogen H2, hydrogen molecule, and hydrogen deuterium and deuterium molecule and hydrogen tritium and tritium molecule and deuterium and tritium. Okay, so these forms the hydrogens are exist in the atmosphere. Okay, understood? Okay, students, today your assignment explain why hydrogen is not placed with the halogens in the periodic table. Explain why hydrogen is not placed with the halogen in the periodic table. Here, page number 101. Take now. Take page number 101. The page number 101, the left side of the page, the last third line onwards, we have to mark. Okay, the electron affinity of hydrogen is much less than that of halogen atoms. Hence, the tendency of hydrogen to form hydride ion is low compared to that of halogens to form the halide ion, as evident from the following reactions. What are the reactions? Half H2 plus 1 electron gives H minus. Half Br2 plus electron gives Br minus. Okay, what is the electron affinity values? Delta H is equal to plus 36 kilocalories per mole. That is the electron affinity enthalpy change of the hydride ion. Okay, here delta H is equal to minus 55 kilocalories per mole. That is the electron affinity value. How much amount of energy released when one electron is added to the orbital of bromine atom, that is the minus 55 kilocalories per mole. Okay, this energy will be very high energy because bromine atom readily accept electrons. Okay, but hydrogen atom not readily accept the electrons, since hydrogen has similarities with alkali metals as well as halogens. Okay, we studied about that. What are the similarities of hydrogen with alkali metals and halogens? Some similarities are exist in alkali metals and some similarities having the halogens atom. So it is difficult to find the right position in the periodic table. However, in most of its compounds, hydrogen exists in +1 oxidation state. Therefore, it is reasonable to place the hydrogen in group 1 along with alkali metals, as shown in the latest periodic table published by IUPAC. Okay, up to here you mark. And the another one, the properties of hydrogen, the page number 102, properties of hydrogen, deuterium and tritium molecule. Okay, if you have interest, you can read what are the atomic mass of hydrogen, deuterium and tritium, number of proton, number of electron, number of neutrons for the protium, deuterium and tritium. Okay, and abundance, we studied about that. Molecular mass for the hydrogen molecule, deuterium molecule and tritium molecule. Okay, and what are the enthalpy of dissociation, bond dissociation energy, what about, and internuclear distance, boiling point, melting point, all. Okay, if you have interest, you can read. Thank you all of you.